So, hello everyone, welcome to Concepts in Chemistry YouTube channel. So, also welcome to our new series, that is Chemistry Concept Booster series. So, this is our new initiative. So, in this series, we will discuss lots of new questions from all branches of chemistry. So, normally these questions you cannot find in previous year paper uh, of NET, GATE, BARC, or IIT-JAM exams, but uh, this yeah, we maintain the quality of questions. We maintain the quality of these questions, keeping in mind the fact that what kind of question normally uh, asked in NET, GATE, BARC, or IIT exam. So these questions uh, are somewhat different type of questions, and I believe that practicing this type of new questions will help you a lot for uh, any competitive exam. So another point I want to inform you that the BARC exam is closer, so this time it will be held in a two phase for chemistry student. So first phase will be on 2nd April, and second phase uh, is on 6th April. So before BARC exam, so uh, we will try to upload as much as maximum questions in this chemistry concept booster series, so that you can practice, and in this way a revision of syllabus will also be done. So let's start. So uh, we already uploaded one video in this series, chemistry concept booster series. So we discussed there are five questions from physical chemistry. So you can find the link in our description box. So this is our sixth questions from uh, in chemistry concept booster series. So we will discuss only one questions in this video. So let's start. So there are four statements given. We have to find the correct statements. So first statement: the efficiency of a Carnot engine will be higher when the temperature of source is increased. So source means high temperature reservoir, instead of decreasing the temperature of sink by the same amount. Sink means low temperature reservoir. So this is some complex statement. So read again. Yeah, after reading first time, so it seems like a complex and very difficult statement. So read again: the efficiency of a Carnot engine will be higher when the temperature of source is increased by some amount. If we increase some amount of temperature of the source, instead of decreasing the temperature of the sink by the same amount, then the efficiency of Carnot engine will be higher. So and statement B: the efficiency of a reversible heat engine, that is Carnot engine, depends only on temperature of sink means low temperature reservoir, and source means high temperature reservoir. So the efficiency of a reversible heat engine depends on temperature and sink and source and nature of the substance. C. The efficiency of a reversible heat engine depends only on temperature of sink and source and independent of nature of the substance. So B and C are quite similar statements. That only difference is that dependency of uh, substance, nature of substance. D statements: theoretically an engine, obviously it's a reversible or heat engine or Carnot engine, will be 100% efficient only when the temperature of the sink is 0. So you have to know the two terms, that sink and source. So source is always the high temperature reservoir, means high temperature, and sink is low temperature reservoir. So let's try to explain every statement. So and then we will find which are correct and which are incorrect statements. So yeah, efficiency of a Carnot engine, we all know that efficiency eta of a Carnot engine is T minus T prime upon T. So T is the temperature of source, means temperature of high temperature reservoir, and T prime is the temperature of sink, means temperature of low temperature reservoir. So see here, this is efficiency. So if we increase T by some amount, so assume T is 50 degrees centigrade or Kelvin, T is 50 Kelvin and T dash is 25 Kelvin. So if we increase T from 50 Kelvin to 60 Kelvin, then this T become 60 Kelvin. This in the denominator also it's become 50 to 60. So this numerator term, whole term, obviously increased, but also the numerator term also increased. So we cannot find without calculation then this exact value exact value of the efficiency by increasing the temperature of the source, means hot high temperature reservoir. Will it be more or less from the original? Original mean before increasing temperature, but you can clearly see that this T prime is the temperature of sink, means temperature of low temperature reservoir. See, if we decrease this term from 25 to 20, then this whole term will increase. There is no change in this numerator term. So sorry, denominator term. So the term in the numerator will increase if we decrease the temperature of the sink. Try to understand. If we decrease the temperature of the sink, then this whole term will increase, but there is no change in this denominator term. So overall efficiency will increase if we uh, decrease the temperature of the source by some amount. But we cannot say without calculation. If we increase the temperature of the source by some amount, then obviously this whole term will increase, because we are increasing this term. Also in the also in the denominator term, this t will be also increased. So we have to calculate to find out that whether which is a easy way to increase the efficiency of a Carnot engine, by increasing the temperature of the source or by decreasing the temperature of the sink. We can uh, we can increase the efficiency of a Carnot engine in two ways. One way is by increasing the temperature of the source or by decreasing the temperature of the sink. So in the questions it is given that the efficiency of a Carnot engine will be higher when the temperature of source is increased by some amount instead of decreasing the temperature of the sink by the same amount. So in this given questions it is said that it is possible to increase the efficiency of a Carnot engine by increasing the temperature of the source by some amount, not by decreasing the temperature of the sink by the same amount. So let's see the calculation. So just assume, so temperature of high temperature reservoir means source if T, and low temperature reservoir means temperature of sink is T prime, then the efficiency is so T minus T prime upon T. So we assume T minus T it as X. We can assume this whole term T minus T prime as X. So X upon T is the efficiency. So if T is increased by del T may be 5 degree 5 Kelvin or 2 Kelvin, 3 Kelvin, any del T. So if T is increased, T is which temperature of source. So if T is increased by del T by some amount, then the efficiency become, so this is neta 1. If we in the first case, if we increase the temperature of the source, means temperature of the hot high temperature reservoir, then this this T term become T plus del T, because we are increasing the temperature by del T of the high temperature reservoir. So T become then T plus del T, and minus T prime is there. Also in the denominator, T plus del T should be there, because we are increasing the temperature of high temperature reservoir, means source. Now T minus T prime, we assumed previously that it is x. So x, T minus T prime is x plus del T. Okay. Now T plus del T is in denominator. Now second case, if we decrease T prime, means if we decrease the temperature of sink, temperature of sink means temperature of low temperature reservoir. T prime is decreased by del T, means same amount, then what will be the efficiency? And the efficiency will be T minus, so we have to put uh, T minus del T in place of T prime, because we are decreasing the temperature of sink by del T. Then in that case, so efficiency will be T minus T prime minus del T. First case, we increase the temperature by del T, that's why T plus del T. Second case, we decrease the temperature by del T of sink. Then in this case, T minus, and in place of T prime, we have to write T minus del T. Here we similarly, in place of T, we write here T plus del T, because we are increasing the temperature. In that case, we have to write T minus del T. So, but in the denominator, only T is there, because this T is temperature of source, not sink. So only T is there. Now it has become T minus del T, T minus T prime plus del T. So we know that T minus T prime we marked as x, so x plus del T by T. So now from these two expression, N1, N2, see, N1 is the efficiency when we increase the temperature of the source by del T, x plus del T by upon T plus del T. This is the efficiency of Carnot engine. Second case, when we decrease the temperature of the sink by same amount, means del T, then the efficiency become x plus del T upon T. So you can see from these two expression, the numerator x plus del T, numerator x plus del T, same. In the second case, only T is there. In that case, only T plus del T is there. So del T is some value, del T has some value, 2, 3, 4, 5, any value Kelvin. So since in this case, in the denominator, T plus del T, some more value is there, so this overall value is less than this value. In this case, only T is there, so in this case T plus del T is there, so the overall value is less than this value. So N2, sorry, not N, neta, efficiency is N2 is neta 2 is greater than neta 1. So we saw that the efficiency is higher when the temperature of the sink is decreased by del T, not the temperature of the source is increased by del T. Yeah, we see here by calculation, by mathematical calculation, that it is, if we have to increase the temperature, if we have to increase the efficiency of Carnot engine, if we have to increase the efficiency of the Carnot engine, then we have to decrease the temperature by some amount we have to decrease the temperature of the sink by some amount. Not we have to increase the temperature of the source by some amount. So clearly we we established the expression of two efficiency. One case, if we increase the temperature of source by del T. Second case, if we decrease the temperature of the sink by del T. So in second case the efficiency will be higher. So we can say that if we have to increase the efficiency of Carnot engine, then we have to decrease the temperature of the sink by some amount of, not 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 uh, not we have to increase the temperature of the source by some amount. So see, so in the uh, statement on, the efficiency of a Carnot engine will be higher when the temperature of source is increased by some amount instead of decreasing the temperature of the sink by the same amount. So it is wrong statement. So this is wrong statement. So the efficiency of a Carnot engine will be higher. So the correct statement will be like that: the efficiency of a Carnot engine will be higher when the temperature of sink is decreased by some amount, not increasing the temperature of the sink by same amount. So this is wrong statement. So the correct statement will be like that: the efficiency of a Carnot engine will be higher when we decreasing the temperature of the sink by some amount and instead of increasing the temperature of the source by the same amount. So this statement is wrong. So we have to decrease the temperature of the sink by some amount to increase the efficiency of Carnot engine, not to increase the temperature of source by some amount. So in B statement, the efficiency of a reversible heat engine depends on temperature of sink and source and nature of the substance. So from this efficiency of Carnot engine, you can say that in this expression only temperature term is there: T temperature of source, T prime temperature of sink. So there is no term of no other term. So that's why the efficiency of a reversible heat engine only depends on temperature of sink and source, and no, it is independent of nature of substance we use. Gas, it is normally anything we can use. It is independent of nature of the substance. So B statement also incorrect. So the efficiency of a reversible heat engine depends only on temperature of sink and source and independent of the nature of the substance. So option C is statement C is also correct. So statement C is correct. A, B are incorrect. Statement C is correct. Now D, theoretically an engine will be 100% efficient only when the temperature of the sink is 0 Kelvin. So C, if the temperature of the T prime is 0, obviously 0 Kelvin. So 0 Kelvin, then need this term become 1. So 1 means 100%, efficiency. So see, in the statement D, statement D is theoretically an engine will be 100% efficient only when the temperature of the sink is 0 Kelvin. Yeah, theoretically if we put temperature of the sink means T prime 0, then neta means Carnot efficiency of Carnot engine become 1, that is 100% efficiency. But actually, yeah, it's theoretically possible, but practically attainment of 0 Kelvin temperature is not possible. So attainment of normally attainment of uh, 0 Kelvin temperature is not possible. So hence 100% efficient engine cannot be constructed practically. Yeah, practically it's not possible to attain 0 Kelvin temperature. So actually Kelvin defines 0 Kelvin is the temperature at which a Carnot engine will be 100% efficient. So Kelvin, scientist Kelvin defines that at 0 Kelvin temperature, the Carnot engine will be 100% efficient. It is theoretically possible, but practically, uh, attainment of 0 Kelvin temperature is not possible. So that's why 100% efficient engine cannot be constructed practically, but theoretically it's possible. So in the statement, it's written like it is written complete. It is clearly written like this: theoretically, an engine will be 100% efficient only when the temperature of the sink is 0 Kelvin. So option D is also correct. So the correct options are C and D. So option C is correct. A is wrong statement. B is also incorrect statement. So normally, you have to some points you have to keep in mind that in Carnot engine, Carnot efficiency of Carnot engine depends only on the temperature of the source and sink, not depends on the substance we substance under uh, uh, consideration, means it's gas, liquid, solid. It's independent of the nature of the substance. And if we have to increase the efficiency of a Carnot engine, then we have to decrease. Then we have to decrease the temperature of the. We have to decrease the temperature of the sink. We have to. So if we want to uh, enhance the efficiency of a Carnot engine, then the option is the correct option. The correct way is to decrease the temperature of the sink. So the correct way is to decrease the temperature of the sink, not increase the temperature of the source. So I hope you all understand these questions, and I believe that you all I believe that you all so yeah. So uh, you all learned some different concepts, and I hope practicing these questions from thermodynamics regarding Carnot engines in a different questions. So I hope some different concepts you learned, and it will help you a lot for solving more questions, different questions from thermodynamics. So that's all for today. So for information, so we will upload. I think more 3-4 videos so before 2nd April. So we will discuss lots of questions from organic chemistry also, and uh, so physical chemistry. So thank you for watching. So stay safe, stay healthy.